Some of the research that I'm doing sort of lies at the intersection of traditional electrical engineering as well as neuroscience. Involves recording signals non-invasively from the brain by recording voltages or signals at the exterior of your head, and taking those signals and creating scenarios whereby we can do signal processing or other types of techniques to in some sense decipher your underlying intent. When I got here to campus, I decided to do some of the traditional research that I've already been working on, but to take somewhat of a risk and try to work on a project that is really wed to both neuroscience and engineering. So this little cap has a bunch of sensors on it, and these little sensors are basically sensing the electrical activity across different areas of your brain. And so some of them are in the vicinity, for example, the motor cortex in different areas of the brain. And what's well known is that the patterns of those signals change depending upon your intent. So as an electrical engineer, that's basically all I need to know. I want to emphasize that none of this would be possible if it was not for my collaborators, especially Tim Bretl in the aerospace engineering and Ed Maclin at the Beckman Institute in the Department of Psychology. We've been working on these problems for over 3 years, just thinking about the right way to conceptualize the problems. And by wedding all of our unique viewpoints together, signals and communication over noisy channels, robotics and control, as well as psychology and underlying neuroscience, we've developed what we think is a unique perspective on how on attempting to enable brain-machine interfaces. One of the contributions that our group has enabled that we think is important is the appropriate use of how you deliver feedback. For example, suppose that you're thinking of a number between 1 and 20. And I get to ask you one question, and you give me a yes or no response. So a smart thing for me to do, if all the numbers are equally likely, is for me to first ask you, is the number less than 10 or is it greater than 10? And based upon that, you say yes or no, and then I hone in again, and you say, okay, is the number less than 5 or greater than 5? And basically what we're asking you is the sentence that you care about, does it come before the sentence I'm displaying on the screen, or does it come after it? So it turns out that all sentences can be sort of ordered. Imagine we could order the set of all sentences. And so we ask the user a binary question. Does the sentence that you care about, does it come before the sentence we show on the screen, or does it come afterwards? This has potential for scenarios where a user has a lost motor function, yet their brain is still intact, and we can take the signals that normally get routed from the brain to the muscles and acquire them right from the brain, and then use them to allow someone to do tasks that they might not be able to do otherwise. If it's your objective to type a letter to your mom, then we should think about our performance objective accordingly. We want to make sure that you can spell out this sentence with your thoughts as fast as possible. Tim and some of his students in the aerospace engineering department have taken it one step further, and have taken these signal processing algorithms and everything that we've developed and used them to actually control a remote control airplane flying over Champaign. This is just the tip of the iceberg. My name is Todd Coleman. I'm an assistant professor in the Department of Electrical and Computer Engineering, and also affiliated with the Neuroscience program.
We are anonymous. We are legion. We do not forgive. We do not forget. Expect us.